Introduction to Blockchains, Part 1.
Good morning, Anita.
A very good morning, Terry.
The explanations that you gave about cryptocurrencies in our last meeting were very useful to me, Anita.
It is pleasing to hear that my inputs are helping you with your project, Terry.
Yes, Anita. But is this knowledge sufficient for me to move on with my project?
No, Terry, as what I have taught you so far are from the perspective of cryptocurrencies. To develop a website that supports Bitcoin transactions, you must know more from the technical aspect, that is, blockchain.
Yes, Anita. We have already come across this term.
You are right, Terry, but you need to know more about blockchains in detail.
Hmm, this seems to be really interesting. Can you explain about this to me?
Sure, Terry. Today I will explain to you about blockchains in detail.
Blockchain.
Blockchain is a mechanism used to track and verify transactions that occur in a cryptocurrency network. Blockchains are literally chains of blocks. These blocks refer to digital information or transactions. Each one of these blocks is related to its previous block through cryptography, thus forming a chain. The cryptographic aspect is not important to understand just yet, but what is important to remember is that each block can contain thousands of transactions that are processed together. This process is called mining. Blockchains are data structures just like a traditional database, but the key difference is that the blockchains are distributed across all nodes throughout the world that participates in maintaining that blockchain. This means that all nodes keep a copy of the entire blockchain and new blocks are only added when all nodes agree on the information that needs to be added. This makes it very difficult to add false information to the blockchain as nodes do not know each other and must first expend electrical energy to find a solution to a complex mathematical function before they win the right to add a block to the blockchain. Only once they find a solution can they broadcast their solution to the network, and if all nodes agree that the work was performed accurately, the block gets added. It should be noted that this algorithm is hard to solve, but easy to prove once the answer has been found. This is known as finding consensus, and each blockchain has a consensus algorithm. In the case of Bitcoin, this would be the SHA-256 hash algorithm. Because each block is related to its previous block through cryptography, the information stored in a blockchain can never be changed, making it immutable. There are ways of changing information, known as a 51% attack, but it is so unlikely in highly decentralized blockchains. In highly decentralized blockchains, nodes do not know one another and therefore cannot entice other nodes to collude with them.
But Anita, is immutability in blockchains important?
Immutability is important because, unlike a database which can be manipulated, corrupted, erased, or destroyed, information in a blockchain is forever provable.
Oh, now I understood, Anita. But I have another doubt.
What is it, Terry?
Is the blockchain traceable?
This is a common question that everyone asks about blockchains. Let me explain to you about block explorers and traceability. A common misconception is that Bitcoin is completely untraceable. The opposite is in fact true. The Bitcoin blockchain is a transparent global ledger that can be accessed from anywhere. Much like internet browsers that interact with the HTTP and TCP or IP protocols, block explorers merely interact with the protocols of the cryptocurrencies they are associated with. As a result, there are many options for block explorers like the one displayed, but with slightly different functionalities. At their core, block explorers are like browsers for the blockchain. With a Bitcoin Explorer, you can investigate the transactions within blocks. Let me show you an example of this, which would be to search by a Bitcoin address to see how many Bitcoins are available to the owner of that address. So, once an address can be associated with a person, their entire transaction history is exposed. It is thus considered a good practice to generate a new address for each transaction if you are seeking privacy. In the case of Bitcoin, the information stored in the blockchain, that is, the transaction level includes the block header, the block number, the transaction sender, the transaction recipient, the solution to the algorithm, the fee to process the transaction, and a timestamp. Now, if we consider a transaction to simply be a sequence of ones and zeros that represents data on a computer, then we can imagine a blockchain to contain any digital information. This is why blockchains can be used in applications other than just money, where the information needs to be immutable.
This is great, Anita.
Yes, Terry, I think we can call it a day with this.
Sure, Anita.
Conclusion.
This is really awesome. I never knew that blockchains can be this much interesting.
Yes, Terry, there is even more interesting information awaiting us. This blockchain is useful in a number of ways, but you have to wait for some time to learn about them.
Sure, Anita. Let's meet some other time to learn more about the uses of blockchain.
Terry, can you brief me on what we have learned today about blockchain?
Sure, Anita.
Summary.
Today we have learned that blockchain is a mechanism that is used to track and verify transactions that happen in a decentralized manner without a central party involved. One such use is transactions that occur in a cryptocurrency network. Blockchains are data structures just like a traditional database, but the key difference is that the blockchains are distributed across all nodes throughout the world that participate in maintaining that blockchain. In highly decentralized blockchains, nodes do not know one another and therefore cannot entice other nodes to collude with them. Much like internet browsers that interact with the HTTP and TCP/IP protocols, block explorers merely interact with the protocols of the cryptocurrencies they are associated with.
Wow, Terry, you are a quick learner. Okay, let us continue our discussion some other time. Bye.
Okay then, bye Anita.